We're looking at number 4. Number 4 says select the properties that complete the two-column proof shown. So we have this proof that we want to finish. It's a two-column proof that most of it's done for you. So this is really just a vocab check. So the first thing you should do when given this problem, I'm not going to do it just due to space of my .cam and all this, but first thing you should do is draw. Draw that. That's the most important part, is you got to draw that. The second thing you need to do, so if you don't have that drawn and you're just watching this video, then probably pause it and do that first. Second thing you need to do is mark the given. So first was draw, second is to mark the givens. Alright, so this is saying that AB is parallel to DE. So these are parallel to one another. And C is a midpoint to AD. That's all we're given. Parallel and congruent. So first thing we have is AB is parallel to DE, which is a given. Then we have BAC, so this angle based off this part, and EDC, why are they going to be congruent? So we have two parallel lines. With the image you drew, I'm going to extend the parallel lines, and extend this transversal. So right here, this transversal, we can see with it extended, because sometimes we're better with a visual, that we are inside the transversal. So if we're inside of it, anything with exterior is out. So it could be alternate interior, because we're alternating in between the different parts of the transversal and they're inside. Corresponding would mean they're on the same side, they're not on the same side. And vertical would mean that they're sharing, or the opposite angles between two lines, which they're not. So alternate interior angles is all that makes sense. Just going to shorthand it, so it's the space. So this is our answer for that one. ACB is congruent to DCE. So ACB, another angle, it's congruent to DCE, and it's saying by vertical angles. Then it's a C is a midpoint of AD given. So therefore AC is congruent to DC, which we wrote already, definition. So why are these congruent? We have an angle, a side, then an angle. And here we have an angle, a side to an angle. In that order. So side to side doesn't work, side angle side. So it looks like it's going to be angle, angle, side. And the final part is if you have two triangles that are congruent, therefore all parts of the triangle are congruent as well. So we would have BC is congruent to CE. Oh, not angle, angle, side. What am I saying? Angle, side, angle. Yeah, make sure you check your work before you go, because it goes from an angle to a side to an angle. It goes from the alternate interior angle to the midpoint side length to the vertical angle. So it's angle, side, angle, not angle, angle, side. Angle, side, angle. So again, these proofs, they're not really going to make you do the entire thing on your own. They're just going to see, do you know the vocab?